bases. So the next unit that we're going to be covering is on acid-base theory. And basically, acid-base theory is just a classification of compounds. So how to classify compounds as either an acid or a base. Okay. Compounds that are acids have these general properties. They taste sour or tart. They react with metals to produce hydrogen gas. They react with bases to form salts. They turn litmus paper red, and their pH ranges from 0 to 7. Okay, actually the word acid comes from this Latin word acidus, meaning sour or tart. It's also closely related to the word acidum, which means vinegar, which is an acid. All right. And before scientists realized it's not a good idea to taste chemicals, they would taste them, and if they tasted sour or tart, they were like, oh, that's probably an acid, right? But we don't do that nowadays. We don't taste any chemicals, so never taste any chemicals that you're not sure of what they are, okay? And then the other side of it is bases. Bases, they taste bitter. Again, do not taste them. They feel slippery. Usually they feel like soapy. They react with acids to form salts. They turn litmus paper blue, and their pH ranges from 7 to 14. Okay, those are general properties. We're not really going to talk about that too much right now. I'm going to actually say that for a little bit later, but I'm just throwing that in there for now. Now, these are some common acids and bases, just to give you an idea here. So, like most citrus fruits are acidic because they contain citric acid, right? Tea, soda, battery acid. I'm sure you heard of battery acid before. Those are all things that are also slightly acidic. Some bases include baking soda, soap, ammonia, lye, antacids are usually basic. Obviously, antacid, they are against acids, right? The opposite of acids. Okay, so those are just some common uses of acids and bases, or not uses, but common acids and bases that you might know. Okay, now this is really what we're going to focus on today. The chemical definition, as well as calculating pH and OH minus concentration. So the chemical definition of an acid is a molecule that gives off H plus ions in water. So if the molecule gives off H plus ions in water, we consider it an acid. So this is called the Arrhenius definition. There's actually 3 different definitions of acids and bases, and we'll talk more about that a little bit later. But right now, we're just going to focus on the Arrhenius, the simplest definition of acids and bases. Okay, so again, acids are molecules that give off H plus in water. So oftentimes you'll see an H in the front of the compound. See, HCl will give off H plus and Cl minus. Okay, this one we call monoprotic because it gives off 1 hydrogen in water. Okay, if you think about it, what is H plus? Well, H plus is a hydrogen atom with a positive charge. Hydrogen atoms, though, they consist of 1 proton and 1 electron. If it loses that electron, now what is it? It is a proton. So H plus is actually just a proton. Okay, so H plus is simply a proton. Okay, so an acid that gives off 1 proton, we call it monoprotic. Acid that gives off 2 hydrogens, so like something like H2SO4, we call that diprotic. And an acid that gives off like 3, like H3PO4, we call that triprotic. Okay, so monoprotic, diprotic, triprotic, but they all give off H plus in solution. So when they're dissolved in water, they give off H plus. Okay, bases, on the other hand, bases are molecules that give off OH minus. in water. Okay, so NaOH is an example. NaOH, OH at the end. You always see the OH at the end. It'll never be in the beginning. It'll always be at the end. Okay, NaOH. NaOH will give off Na plus and OH minus. Okay, barium hydroxide, BaOH2. Barium hydroxide will give off barium 2 plus and 2 OH minus. We don't use mono and di for this really. I mean, actually we can, but we would actually, I'm going to change it because we actually do say this. We say mono basic. And what do you think we say for this one? We say dibasic. Dibasic. I'll add that in there. You do say that actually. I kind of just like slipped my mind. Dibasic. So they give off 2 OH minus in water. Okay. All right. So that's how to identify them. Usually you'll have H at the beginning of the compound if it's an acid, OH minus at the end if it's a base. Okay. The pH scale. So I'm sure, I know like most people have heard of pH before. Okay, maybe you don't know what it is, but you've heard of it before. The pH scale is just used to determine how acidic our basic compound is. It goes from 1 to 14, typically. However, pH can be 0. It can be negative. It can be actually more than 14 too. But generally, we say it just goes from 1 to 14 or 0 to 14. And we say 1 to 7 is acidic, 7 is neutral, 7 to 14 is basic. So kind of looks like this, right? So somewhere in the middle, 7 is neutral. Acidic is all the way from 0 to 7 or 1 to 7. It really, like I said, the range can go further beyond. It can go beyond 0 and 14, but typically we don't think of it that way. Most things will lie between 0 and 14. Okay. Some really acidic stuff is like battery acid, stomach acid. Lemon's actually pretty acidic. Vinegar's a little bit, and then it gets less and less acidic. Tomato, coffee, milk, slightly acidic. Water is usually a pH of 7. Then we get into more basic stuff like blood and baking soda, antacid tablets, ammonia. And then we get more and more basic with like something like soap and bleach and drain cleaner. Drain cleaner is very, very basic. Very, very basic. Okay. Now, how do we calculate these things? Well, these are the formulas we're going to use. pH equals negative log of H plus. So we're taking the negative log of the H plus concentration in solution. So whatever the H plus concentration is. POH. So POH is just the kind of basic form of pH. So it's the negative log of the OH minus concentration. Okay. And then pH plus POH of a specific compound, of a specific solution. If you have the pH of a solution and the POH, when you add them together, they'll always add up to 14. Okay. So even when you have H plus in solution, you still have OH minus in solution too. You have a small amount as well. This is known as the autoionization constant of water. Like water will always have an H plus and OH minus concentration. Actually, all solutions will have an H plus and OH minus concentration that when you multiply them together, these two together, they'll equal 1 times 10 to the negative 14th. Okay, this number is called the Kw. Okay, this 1 times 10 to the negative 14th, this is the Kw. So I forgot to really explain this in my notes here. Kw. And this is a constant for all aqueous solutions or aqueous solutions. Okay, So if H plus concentration is super high, the OH minus concentration can be very low. Okay. Just because you have H plus doesn't mean you don't have OH minus. You still have OH minus, just you have a smaller amount of it. Okay, we'll talk kind of more about this principle. Okay, we'll talk more about this principle another day. I'm going to talk about what the autoionization constant, so it's the, I should say, autoionization for water. So it's a constant. It's always the same. And again, we'll talk about this. I'll talk about the principle another day, but just know these equations. Know that in a solution, the pH is equal to negative log of OH. The POH is equal to negative log of OH minus. pH plus POH of any solution will always equal 14. And the H plus and OH minus concentration, if you multiply them together in any solution, it will always be 1 times 10 to the negative 14. And this is that Kw constant. Okay. So with this information, you're going to do the worksheet here. Okay, so let's go over and do some examples here. So up at the top here, you're just simply identifying the following chemicals as either being acidic, basic, or neutral. Okay? Or Na. Neither. I didn't write neutral because, yeah. But so, for example, this one, O2. O2, it doesn't have an H in the front, doesn't have OH in the minus, OH at the end, so therefore it must be neither. Okay, KOH, KOH, it has OH at the end, therefore it must be basic. HI, HI has an H in the front, therefore it must be acidic. It's usually not as easy as this, but this is a good start. Okay, this is a good start. If you see something with H in the front, acidic. OH at the end, basic. If it doesn't have either, it's neither. Pretty simple, right? Okay, so once you get that down, then you're going to be doing calculations with pH, POH, and OH minus. Okay, so the first part, number 1, says find the pH of the solution with the following H plus concentrations. Okay, so for part 1 here, you're going to be calculating the pH of all these solutions. So these are the H plus concentrations. Okay, so this is the H plus concentration of this solution. So if you want to find the pH, what you're going to do is you take the negative log of the H plus concentration. I typically just plug into my calculator as log of this number. Okay, so you're going to just have log of 1.15 times 10, and then in your calculator, you use this little caret. The caret will give you the exponent. So if you look on your calculator, you'll see a caret. They call that a caret. And 10 to the negative 6. So you're plugging in just like that in your calculator. Okay, some calculators will automatically make it a superscript, and some will just leave it like this. Okay, but you do hit log first, and then this. If you're using a graphing calculator. If you're using a scientific calculator that's not necessarily a graphing calculator, sometimes what you have to do is you have to plug in this number first and then hit log, and it'll take the log of the number. Okay, so get kind of warmed up with your calculator. Make friends with it. Okay, so that's how you find pH. Then here, if you want to find the H plus and the POH of the following solutions using this. Oh, I forgot to put an example here. I'll put one down. So in order to find actually, they tell you use this one right here. This is an example for finding the H plus concentration. But POH, I didn't put an example because it's just pH plus POH equals 14. So if pH is 13, Then POH is just 14 minus 3, which is 11. Okay, they have to add up. pH plus POH have to add up to be 14. So that's pretty simple. Okay, then in order to find H plus concentration with pH values, so I kind of screwed that up here, but I should have put the example up here and then just continue down here. But anyway, so this, all you're doing is you're doing like the opposite of log, and the opposite of log is 10 to the power. So here, to find H plus concentration given pH, you take 10 to the power of the negative pH. Okay, so 10 to the negative 8.3, if that's what the pH is. If the pH is 8.3, you take 10 to the negative 8.3, and when you plug it in your calculator, you'll get a number that looks like this. Sometimes in your calculator, it'll say 5e to the negative 9th, and that just means times 10 to the negative 9. Okay. Okay, so that's H plus. Oh, I think this one I forgot to change. Oh man, I got to change that then. So all of your this is wrong here. This should not say pH values. So on your sheet, number 4, the directions, it looks like the directions are right, just the label here. Find H plus concentration with the following pH values. That's not right, but the rest of this is right. So you're calculating the concentration of OH minus in a water solution. So you're basically calculating either OH minus or H plus given one or the other. So for example here, this one you're given that the OH minus concentration is 2.3 times 10 to the negative third. Sorry, you're given that the H plus concentration is that 2.3 times 10 to the negative third, and you want to know the OH minus concentration. So you're going to use that Kw, that 1 times 10 to the negative 14th is equal to H plus times OH minus. Okay, H plus was 2.3 times 10 to the negative third. Then you rearrange the equation to solve for OH minus, and you get this, and then you get OH minus equals that. Sorry about that. This directions are wrong. I'll have to fix that. So find H plus or OH minus concentrations using Kw. I should say that. Sorry about that. Directions are wrong, but the rest is right. Okay, so once you practice that, now you'll be able to figure out H plus, OH minus. You have ways to figure out all those things. Then you got to fill in this chart. So basically, you're using everything you just did up there before to fill this out. So for example here, POH is just 14 minus 2. So 14 minus 2 is 12. So the POH is 12. Okay. H plus concentration is just 10 to the negative pH. So it's just 10 to the negative 2. So you can just say 1 times 10 to the negative 2. OH minus concentration is just the negative log of, 10 to the negative POH. So 10 to the negative POH. So 1 times 10 to the negative 12. And then this, because it's pH of 2, it's actually an acid. So super simple. All right. I kept them pretty simple. They're all pretty simple ones. All right, and that's it. That's it. That's your work for today. So right now, you're just going to try and get that done. And I'll see you guys tomorrow.